content is for educational purposes only, drawing from our professional and educational experiences and opinions. Please use this information at your own personal or professional discretion. We are not liable for anything you do with this information.
Good evening. Welcome to Ask the Lady Electrical Inspector podcast. I am your host, Tabatha L. Tonight, I will share important National Electrical Code requirements specifically related to separately derived systems, which are electrical systems that obtain power independent of the building's main utility power source, often involving a different grouping and neutral system. I will explain what these systems are, including specific definitions from the National Electrical Code, Article 100, highlighting their distinctive features, such as equipment bonding and grounding practices. Additionally, I will discuss common reasons why these systems often fail electrical inspections, such as improper grounding, lack of clear labeling. Stay tuned as I outline the field inspection criteria set by the authority having jurisdiction and the National Electrical Code standards necessary to ensure compliance and safety. Join me this evening as we dive into the importance of separately derived systems, understanding their roles in the overall electrical safety of a building, and learn about the potential consequences such as electrical hazards and code violations that can occur if vital authority having jurisdiction and NEC requirements are neglected. Let's explore the world of electrical safety together, ensuring that our installations are both safe and code compliant. According to the National Electrical Code, Article 100, a separately derived system is defined as a premise wiring system whose power is obtained from a source of electrical energy or equipment other than a service. Such systems have no direct electrical connections, including solidly grounded neutral conductors to supply conductors originating from another system. This means that the system operates independently from the main electrical supply, ensuring safety and flexibility in complex installations. It's important to note that the term service specifically refers to the electrical utility power supplied by a utility company, distinguishing it from another energy source, such as generators, batteries, or renewable sources like photovoltaic systems. Separately derived systems usually feature two or more sources with phase and neutral conductors completely isolated from each other. While each source neutral can be individually grounded and connected to a common grounding bus, the neutrals are not interconnected with each other. This segregation ensures that the independence of each power source, allowing for isolation, operations, and reducing the risk of fault propagations. Additionally, neutrals may be grounded through an impedance device such as a resistor or reactor allowed by the National Electrical Code Article 250.28b. This setup helps control fault current, reduce electromagnetic interference, EMI, and prevents unwanted neutral to ground bonds that could compromise system safety. A system can be considered separately derived either internally within a building or structure mainly through the use of an isolation transformer or by employing a generator or alternated power source with a transfer switch that interrupts the neutral conductor. The primary feature is the absence of a direct electrical connection, including the grounded neutral conductor, to another electrical source except for grounding and bonding connections that are properly established to ensure safe operation and code compliance. Examples of separately derived systems: isolated transformers. These are the most common methods of creating a separately derived system inside a building or facility. The primary and the secondary windings of the transformer are physically and electrically isolated, meaning no direct wire connection exists between them. Power is transferred via electromagnetic induction, allowing the secondary side to function as an independent electrical source with its own dedicated grounding system. Such systems must have a dedicated grounding electrode system, such as a ground rod or plate, and a single system bonding jumper that connects the derived neutral to the ground at the source of or first disconnecting means. Examples include delta Y, delta delta, and Y-Y transformers, which can serve as separately derived systems when their primary and secondary neutrals are not solidly interconnected. Autotransfers, which share windings between the primary and the secondary, do not qualify as a separately derived system due to their inherent electrical connections. Another separately derived system, generators. When installed with a transfer switch that isolates all ungrounded, hot, and grounded neutral conductors from the utility source, these systems are considered separately derived. The transfer switch, typically a 4-pole switch or 3-phase system or a 3-pole switch for a single-phase system, must interrupt all conductors to prevent backfeeding. The generator, neutral, must be bonded to its frame and connected to a grounding electrode, establishing it as a distinct power source separate from the utility. Batteries. Inverters based systems where the output is not interconnected to the utility. A stationary standby battery system can be classified as separately derived if wired correctly. The independence hinge on how the battery system is wired in relation to the normal power source, with proper transfer equipment and grounding employed to maintain separation. Photovoltaic systems, PV systems. A PV system with a neutral to ground bond at the inverter creates a new source that is not directly connected to the utility service conductors. Off-grid PV systems are inherently separately derived because they operate independently of the utility grid and have their own grounding system. These systems typically include transformers or inverters with built-in transformers to ensure isolation. This comprehensive understanding of separately derived systems, bonding, and grounding is essential for the National Electrical Code compliance. Proper implementation promotes electrical safety, reduces the risk of faults, and ensure reliable operation of complex electrical installations utilizing separate power sources, especially in critical applications like emergency power or specialized industrial processes. The National Electrical Code articles to follow when bonding and grounding a separately derived system. When installing electrical systems, it is crucial to refer to the correct electrical code article for bonding and grounding of separately derived systems to ensure safety and compliance. Proper identification of these relevant code articles minimize electrical hazards such as shock risk and equipment damage. Determining the correct code article. The choice of the appropriate National Electrical Code article depends on the type of separately derived system being installed. Each system has specific requirements for bonding and grounding to ensure operations. So the requirements, standards reference to install generators. So here are those requirements, standards, and the references. So to install a generator, a permit will be required. If it's a whole house generator, you will need a generator load calculation sheet. The generator policy, Ordinance 1102.080.8 approval. Seismic requirements. Please read the seismic requirements. The key National Electrical Code articles for separately derived systems for transformers would be 450. This article addressed installation practices, grounding, and bonding specifically for transformers. Refer to Article 450.10 for comprehensive grounding and bonding procedures. Refer to Article 250 Part 2 for system grounding and bonding specific applicable to transformer systems. Article 250.12 emphasizing maintaining clear and oxy-free surfaces during installations to ensure grounding. Article 250.30 covers the grounding and bonding requirements for transformers, separately derived systems, which are systems that are electrically isolated from another system. Generators, Article 445. This article provides general guidelines for generator installations, including environmental considerations and safety protocols. National Electrical Code Article 250 applies independently to generators, especially when they are used as separately derived systems, outlined in Article 250.30. For permanently installed generators, Article 250.35 provides specific grounding and bonding criteria, referencing Article 250.30 for detailed requirements. Article 250.24 discusses service grounding practices for generators. Article 250.28 specifies requirements for main bonding jumpers and system bonding jumpers related to generator systems. Article 250.34 addresses grounding systems for portable or vehicle-mounted generators. Article 250.66 offers recommendations for sizing grounding electroconductors in generator setups. Additional articles to look for in generators would include Article 700 covers the emergency systems designed to provide critical power during outages. Article 701 pertains to legally required standby systems that must remain operational under emergency conditions. Article 702 discusses optional standby generators and their installation considerations. Another article for separately derived systems, stationary standby batteries. Please refer to Article 480, which provide detailed guidelines for the installation, grounding, and maintenance of stationary batteries used in backup power systems. Grounding and bonding requirements are primarily outlined in Article 250.30. Proper sizing of the grounding electrode, 250.66, is essential for safety. Photovoltaic systems, PV systems, refer to Article 690, which specifically address the unique bonding and grounding procedures necessary for solar panels systems. As with other systems, grounding and bonding are primarily governed by Article 250.30. Grounding electrode conductor sizing should be followed in Article 250.66, adhering to the specific articles and guidelines. Common reasons. Now I will give common reasons why separately derived systems often fail electrical inspections, including specific issues related to transformer generators and other systems. Transformers. Common reasons why transformers fail inspection involves unclean bonding surfaces, undersized grounding electrode conductors, and ventilation distance from the wall that do not follow the manufacturer's instructions, potentially leading to overheating or fire hazards. Generators. Common reasons why these fail. The failures often occur due to incorrect service characteristics, such as incorrect voltage or current ratings, incorrect service characteristics overhead or underground, and missing crucial utility information like the 9-digit utility premise number. Additionally, inaccurate load calculations, failure to meet seismic requirements is another one, and improper torquing of connections and incorrect grounding practices can lead to inspection failures. If the generator have a switch neutral conductor and not directly connected to another system, it's essential that this configuration is correctly bonded. The main water grounding electrode should terminate inside the first means of disconnect, such as the automatic transfer switch. The main grounding electrode terminates inside the transfer switch. Article 250.24.4. If it's in a home or a residential, the house panel now becomes a subpanel. Separate the neutrals and the grounding conductors. Article 408.40. Another reason why the generators commonly fail, is unlisted transition fittings. You must have listed transition fittings. Trade name go-to are not allowed. You're not allowed to go to between a rigid heavy wall coupling and transition to different raceways. Article 315, fittings and connectors shall be used only with specific wiring methods for which they are designed and listed. Expansion fittings required from Article 352.44 of the National Electrical Code requires that expansion fittings be installed for PVC conduits to compensate for thermal expansion and contraction where the length change or into the ground are greater than 1.25 inches. Generators are fail inspection because sometimes they are obstructed by the utility meter. You cannot place a generator directly in front of the utility meter. So look at table Article 110.26, the working clearance. The depth of the trench to bury the raceway. 18 inches is the minimum if you're residential, but to make sure you get the proper depth. Article 300.5. Table 300.5, minimum covered requirements. Bonding bushings required for metal raceways containing service conductors. Article 250.92. Labels to notify a separate source of power is on the property. You need labels. Article 700.7 also specifies that. Now, we'll go to stationary standby batteries. Reasons why these systems often fail inspections. Failure to ventilation. Ventilation is a main problem with the batteries. Proper signage. Another problem with the battery installations are listed panic hardware and emergency egressing hardware. Also, check for the building standards to make sure that battery room, it needs a drainage. It needs drainage pipe. Now I'll go to the photovoltaic PV systems. Failures typically involve out of sequence inspections. No rough cover was called in prior to the final inspection. This includes not verifying listed solar equipment during the rough end stage, missing or approved set of plans, and the permit is not on site. Another key issue includes not following the approved set of plans, improper main disconnect installation on detached structures. Disconnects must disconnect all ungrounded conductors and inadequate signage. And again, for this type of installation, everything must be listed. Unlisted transition fittings, unlisted panels, also unlisted circuit breakers for the PV systems. That is an issue. And those are frequent violations that compromise the safety and the code compliance. Missing grounding electrodes need to be installed from where the water enters the premise to the first means of disconnect. Also, service disconnects must be grouped together. National Electrical Code 230.72. Either side, inside or outside. The internal panel from the exterior disconnect is now a subpanel. Remember that. All grounds and neutrals to be separated. Also, when you're leaving your first means of disconnect, you must now carry a 4-wire conductor. National Electrical Code 250.142. You need a SCR 4-wire service rated conductor must run from the first means of disconnect to the subpanel. Grounding electrode conductor from the water pipe must be continuous. Article 250.64C. Tonight, I have shared detailed reasons why separately derived systems are essential and beneficial in the electrical installations. These systems are used to isolate specific electrical loads and enhance safety, especially in sensitive environments. I have identified and addressed key National Electrical Code requirements, including relevant code articles from 250 on grounding and bonding, as well as articles directly pertaining to separately derived systems. This guidance helps electricians, inspectors, and electrical professionals understand that these systems are considered separate from another electrical source unless properly grounded and bonded, ensuring compliance and safety. It is my sincere hope and desire that this comprehensive information supports our community's electrical safety concerns, helps prevent failures, and promote best practices. When handling large-scale commercial projects or residential projects, many challenges can arise, such as delivery issues, code compliance, and unforeseen technical obstacles. My podcast aims to proactively address potential setbacks during the initial planning and design phase of your electrical projects. While unexpected hiccups can occur, my goal is to quickly identify and resolve electrical issues to keep projects moving forward efficiently. Effective communication with both the electrical contractor and the general contractor is crucial. It's also important to clarify expectations with municipalities and the authority having jurisdiction. I represent and ensure all work adheres to the minimum requirement of the National Electrical Code. Requirements included updates and new code amendments. Join me on Wednesday, November the 19th, for a discussion on gas systems that require a dedicated electrical circuit. We will explore the purpose of this circuit, common pitfalls during installation and inspections, and the best practices to ensure compliance and safety. Visit my YouTube channel where I post videos demonstrating common mistakes in electrical inspections. These videos provide practical insight into best practices, common errors to avoid, and tips for maintaining safe, code-compliant electrical systems. If you're interested in expanding your knowledge of the electrical standards and best practices, check out the list of 60 best electrical podcasts available at podcast.feedspot.com/electricians podcast for valuable resources and industry insights. Feel free to reach out on social media with questions, comments, or topic suggestions. You can find me on Facebook, Instagram, and YouTube under the name Ask the Lady Electrical Inspector, or email me at askthelady.electricalinspector@gmail.com for more detailed discussions or to share your ideals. Let's collaborate to ensure our electrical systems are safe, reliable, and up to code. Your safety and your compliance are my top priority. Thank you for your time and have a great night.